Greetings, a little video to show you how to do linear regression. So this is from section 4.4, problem number 9. The following table shows the number of newspaper subscriptions in Middletown, USA, where T represents the number of years since 2002, that is T is 0 in 2002, and S of T represents the total subscriptions each year measured in thousands. Use your calculator to determine the equation of the regression line round to 2 decimal places. Determine the regression equation in y equals ax plus b form and write it here, and then rewrite it in function notation s of t equals at plus b form here. Okay, so let's get after the calculator. So if we go ahead and get the calculator up here, I've gone ahead and entered in the data already. I don't want you to have to sit and watch me do that, but let me show where you go to do that in case you don't know. You press your stat key. Once you've pressed your stat key, you press enter, and then you will be greeted with L1, L2, L3. If for whatever reason you are not seeing these lists here, go back to hit your stat key and go down to option number 5 here, set up editor. Hit an enter. It'll say done, and then go back and say stat and say edit, and you should see L1, L2, L3. That should reset the data editor for you, okay? All right, I've got the numbers in. I put the X's, or the T's in this case, in L1, and the S of T's, or the Y's, into L2. So now what I need to do is go and do a regression on it. So I'm going to press stat again, but this time I'm going to go hit the right arrow to get over to calc. And I want to get a linear regression. So we'll go ahead and choose option number 4 here. Just a word of warning, in statistics courses there is another version of this command. It's option number 8, and they write it as a plus bx. Just show you down here just for completeness. Okay, they use that version in stats classes, but hey, we're not in stats yet, we're in intermediate algebra, so we'll go ahead and use option number 4 here. Okay, hit an enter. It's going to ask you where your X list is, it's going to ask you where your Y list is, ask you where the frequency list is, ask you where you want to store it, and then ask you to actually calculate it. Now, if you're in an older calculator, like a TI-83, it would have come up with just lint reg AX plus B. This is what you would have seen on your screen, just the thing that's highlighted there. And in that case, all you got to do is hit an enter again, because the defaults are L1 and L2. Now, if you want to store your regression equation, don't ever touch the freak, by the way, leave that alone. If you want to store your regression equation, there is an option here, you can do that. To do that, you're going to press the vars key. Then you're going to press Y vars by hitting the right arrow. Then you go to option number 1 for a function. And then you grab Y1. Now all that does is that tells the calculator to take whatever results from your regression analysis and store it into Y1. Alternately, that's completely optional, by the way. Alternately, you can just type it in, and that works too. Okay, we'll go down to calculate, and notice, boom, it creates the regression equation for us. So A is equal to negative 51.56, and B is equal to 448.2. All right, so they want us to round to 2 decimal places here. By the way, the R squared and R can be ignored for this class. If yours is not showing an R squared and an R, don't worry about that. They'll show you that when you take stats, okay? Okay, so let's go ahead and get our pencil out here so we can do some drawing. And we get Y, come on pencil, you can work, there we go. Y equals AX plus B is what we want, so we need to know what A is and we need to know what B is. So A is negative 51.65. Times X plus our B, and our B was 448.2. We'll go 2-0 because they said round it off to 2 places, so what the heck, we'll put a 2-0 there just to show we were doing it. Okay, now go ahead and put it in function notation. S of t is equal to negative 51.65 t this time, okay, plus 448. Oh, I'm just going to leave it as 0.2. We'll just roll with the love there, okay? Use a graphing calculator to create a scatter plot of the data and set the linear regression equation. So in other words, we want to put the scatter plot down and we want to put the graph over the top of it of our line. All right, so let's go back to the calculator. So this is a few keystrokes, but if you go slow, we'll figure it out. We're going to go second y equals to get into the stats plots menu. Once you're in there, go to plot 1. Turn plot 1 on. Hit the down arrow to select the type. The type we want is the very first one, which is a scatter plot. You can hit an enter if that's not highlighted. Make sure your X list is L1 and your Y list is L2. To change those, the simplest way to do that is hit a second and the number 1. That'll put an L1 in there for you. Similarly, if we hit a second and the number 2, it'll put an L2 for you in there in case those happen to be set to different lists. Okay, once we've done that, we're all set and ready to go here. We're going to do a second to quit to get out of this window. So hit second and mode to quit to go back up to home screen. Now press your zoom key. And from your zoom key, if you scroll down on this list of zoom, you'll find that there is a zoom stat under option number 9. And so it'll take a look at our data set and it'll set up an appropriate window for us and do everything we want it to do all in one swell swoop. So just hit an enter. And notice since I did the store regression equation, it actually plotted the regression equation right on top of my scatter plot. Now, if you did not see the regression equation there, then you need to manually come back into your y equals here, and you need to enter into y1 the negative 51.65x plus 448.2. Now, if you notice, I also happen to accidentally still have another graph on here. Let's get that out of there because that showed up on my scatter plot, and I don't want that in there. So if you have something in y2 or any of the remaining y equals, you might want to clear those out before you do your graph. Okay, so let's go back to the graph here. We see this glorious scatter plot. Now, what they want from us is they want a couple of pieces of information besides a good sketch of this. They want to know what our window settings are. So let's go ahead and press on window here, and we're going to go ahead and copy those window settings back over to our homework. So we see that the negative 0.8 was our x min, negative 0.8 was our x min, 8.8 was our x max, and then our y min was negative 23.51, and our y max was 516.51. Okay, cool. So now we're going to go back, just get ourselves one more peek at this thing. I think we can make a reasonable copy of that. I'm going to get this out of the way. It will be off of your screen, but I'll still be able to see it. Just give me a second here. I'm going to move it. I'll bring it back when we need it. Okay, so got to come in here. I'm going to go ahead and use my line tool. And I'm going to make myself a glorious X and Y axes here. There's my Y axis. There's my X axis. And then come back in here and grab my pencil again. And let's go ahead and make some points. So there's that point and then roughly that point. So I'm just looking at it while I'm drawing here to try and get a pretty good copy of what I'm seeing on the screen. Okay? I just want you to rough it out to see, just make sure you got it. Okay, so let's go ahead and put in the line of best fit here. Let's go ahead and put in my scatter plot line. So if I do that, it looks not quite unlike, but similar to that. Okay, great. All right, now one other thing that we should do, getting my pencil back out, this is actually a really important thing, is we should label our axes so we know what is on what axes. So if we scroll back up for a moment, notice that the time was measured in years. So this is the t-axis right here. But really important also is to put years. Is it in minutes, days, years, decades, centuries? What is the measurement of time, right? And on the vertical axis, that's our S of t. And so that's our subscriptions. And our subscriptions, right, were what? They were measured in thousands, right? So total subscriptions in thousands. So subscriptions, and this is in thousands. Okay, so now I'm feeling pretty good about my graph, got all the information I need on there. Let's move on. It says, based on your graph above, Do the data appear to be exactly linear, approximately linear, or not linear? Explain. Well, I'm going with approximately linear because if it was exactly linear, all of my points would have fallen exactly on the line, and they don't. But that said, it looks like a line is a really good model of the relationship between time and the number of subscriptions per year. So I would say the line is doing a good job of fitting it, isn't it? My window got bumped over a bit, didn't it? I'll just fix that for you. So the line fits the data pretty well. The line fits the data well, but not exact. Remember, again, exact means that line would have gone through every point. But pretty darn good fit, okay? All right, let's go down to part D. It says, what is the slope of your regression line for S of t, and what is the meaning of that in context of this problem? Okay, so that's a good question, right? That's something that we want to get good at. That is, interpreting the slope and the y-intercept and what their meaning are. So if you recall, we had a negative slope here. Our negative slope turned out to be negative 51.65. So the slope, or if you want to use an m, that's fine, is equal to negative 51.65. Okay, now that was in what units? Well, the way you want to interpret slope, let me clean this up a little bit so I make that look more like a 5 there. Okay, you guys got it. That's 5. Okay, so the way to interpret the slope, really the best way to think about that is go back and look at the graph. So notice that the slope is the rise over the run. It's the change in y over the change in x. It's the change in subscriptions over the years. So the numerator is subscriptions, the denominator is in years. So we get negative 51.65 thousand less subscriptions per year. So if we think about that by multiplying through by that 1,000, in other words, if we take the 51.65 and you multiply that times 1,000, right, then that moves the decimal point over 3 places and gives you back 51,650 subscriptions per year that are being lost. Okay, so maybe a cleaner way of saying this is that you lose 51,650 subscriptions per year. A little less geek and a lot more comprehensible to the general public if you write it like that. Okay, what is the vertical intercept of the linear regression model for S of t, and what is the meaning with respect to this problem? Well, that was the 448.2. So 448.2, that was our vertical intercept or our y-intercept. And what does that mean with respect to this problem? Well, again, that's number of subscriptions in this case. Okay, so our vertical intercept says at time 0, which, let's go back up to our original data here. That's starting, I believe, in 2002. So in 2002, we had 448.2 thousand subscriptions. So in 2002, which is t equal to 0, there were, well, should we go ahead and multiply that by 1,000 again? In other words, move the decimal point 3 places. So that would be, what, 448,200. So there were 448,200 subscriptions. Okay, so obviously they are losing a lot of subscriptions per year, and so People are not reading things on paper anymore. That's probably the good way of thinking about it. I was in Costco the other day, and a woman was talking to another by the stack of the books saying, wow, these will all be relics in just a few years. Nobody will be buying paper books. I don't think that's true, but at least the data is trending towards less people are buying paper and more people are reading things online. Okay, use your linear regression equation to estimate the total number of subscriptions in 2007. Now notice 2007 is t equals to 5 because t equals 0 in 2002, so 5 more years down the line is 2007. So to do that, let's go ahead and bring the calculator back in here. So if I bring in the calculator back here, I can go back out to the home screen here, and I can say, okay, let's move it over so we can see our numbers a little bit cleaner here. So we've got negative 51 point, let's see, what was the rest of my number? 65. So negative 51.65. And I'm multiplying that times 5. And I'm going to add to that my 448.2. So that says, oh, that says I didn't get the plus in there. Sorry about that. Part of the problem with using this calculator, that being the one on the computer, is you don't have that sensation of touch that you actually possibly did hit the plus key when you meant to. There we go. Okay. Yeah, because I obviously know that number's not right. I didn't have a negative number of subscriptions, okay? So in 2007, the predicted number of subscriptions is 189.95 thousand. Or if we move over our decimal point again, it's 189,950. Let's make that a little bit better. Sorry about that. There we go. Liking that better. Okay, use your linear regression equation to estimate the total number of subscriptions in 2004. How does this value compare to the data in the table? Okay, so 2004 would be what? That's going to be t is equal to 2, right? Because we started in 2002, so 2 years later would be 2004. Okay, so that says we're going to look at, let's write this one out completely, like we did in the last one here. That's going to be S of 2 is equal to negative 51 point, look at my equation here, 65 times 2 plus 448 point, I believe 2, yes, all right. Okay, so we'll go ahead and do that calculation on the calculator. Hopefully I'll do it correctly this time. Let's see if that dream can come true here. So negative 51.65 times 2 plus 448.2, and voila, we get we get 344,900. So there was 344,900 subscriptions. Now, they want us to compare that to the table. So, in other words, at t equals to 2, what were the subscriptions? We can go back and actually look at our table for that. Or, of course, you can scroll back up on the page. And there were what? Slightly more than that. There were 372,000 subscriptions, excuse me, in 2004. All right, so our model is slightly underestimating it. If we look at the scatter plot, that makes sense. And notice that that point is above the regression line, which tells us that the regression line, slightly underestimated that value at that time. Okay. All right, so use your linear regression equation to estimate the year in which the calculation will be 100,000, round to the closest whole year. Remember, S of t is measured in thousands, so solve S of t is equal to 100. That was really nice of them to give us this reminder. Don't expect that when you take statistics. They will not give you the reminder. They're going to be mean and not do that for you, okay? So what they're saying is come in and set S of t equal to 100 and solve the following linear equation. All right, so our first job is going to be to subtract 448.2 from both sides. So if we do that, I'm going to take 100, subtract from that 448.2, hit an enter, and we get negative 348.2. And that's equal to negative 51.65x, okay? So now what I want to do is I want to take that negative 348.2 and divide that by negative 51.65. Notice I didn't retype in the number. If I hit an ants, it gives me back the, if I hit the divide symbol, it just put ants divided by negative 51.65 once I typed in that number. That's because ants is the last thing you had on the calculator, okay? And so it gives me back 6.74, okay? So 6.74 is approximately equal to x, okay? All righty. So they tell us to take that number and round it off to the nearest year. So that's going to be approximately 7 years from 2002, okay? So what that tells us is, moving right along with that, so then what year would that be, okay? Because they want to know, estimate the year in. They don't want to know how many years since 2002. They want to know the actual year. So that's going to be at about 2009. So roughly in 2009, they're down to 100,000 subscriptions. Okay, I think that's it. Yes, we're going on to the Appalachian Trail after that. So that's the last bit of this problem. Well, it was a little bit long, but it's kind of a long problem. If you have any additional questions with it, do not be shy about posting those to the Q&A forum.